This is to introduce the final project of the course 495. In this project, I implemented several small applications using reinforcement learning. The first part is the introduction of RL. RL has the following features. There is no supervisor, only reward signal. The feedback signal has a time delay. It processes sequence data rather than independent identically distributed data. The action of the learning agent affects its subsequent data entry. In classic video game, agent is free to move and corresponds to the player. Actions is made by agents, including moving up and selling items. Rewards is obtained by the agent, including gold coins and killing other players. Environment refers to the map or room where the agent is located. State of the current state of the agent, such as being located in a particular square or corner of a room in the map. Goal is to get as many rewards as possible. Use following functions to present state space and state transition probability. Using the state space, the action space, and the state transition probability is able to write the step function. Special attention. The input of the step function is an action, and the output is the action in the next moment. The return whether it is terminated, the debugging information. Then use rendering function to create a grid, circle 1 and circle 2, gold and robot. Next, start setting the position of the robot. The position of the robot is different depending on its current state. And this is the result figure of the grid game. The second one is to use dynamic program to implement grid game. The first one is to implement grid game with average policy. The left figure is the output of the first run, and the right one is the output of the last run. We can see the convergence valuation of the state. Next one is to use iterate policy to implement grid game and the results of the first run and the last run. The third one is to use Gym to implement a Sokoban game. The figure showed in the algorithm of Q-learning. Step 1 is to initialize the Q value. Step 2, throughout the life cycle until the maximum number of training is reached, or the training is manually aborted. Step 3, pick an action. Select an action A under the states estimated based on the current Q value. Step 4, evaluation. Take action A and observe the state of the output S and reward R. Then we update the function. Sarsa is similar to Q-learning. However, when selecting the action of the new state, Q-learning uses the greedy strategy that it selects the new A with the largest value and only calculate which new A can make Q get the maximum. The value does not really take this action new A, while Sarsa will use the epsilon greedy strategy and actually adopt this action new A. And then use temporal difference to implement the game, and the result figure is shown. And that's all.